What is the degree of numerator? Suppose this is s minus 1 bracket square divided by
2,
s
sir.
into s, s plus 1 and s minus 3. So degree of numerator is 2 and degree of denominator is 3. Once again, degree of numerator is less than degree of denominator, so you can apply partial fraction method. Now this can be represented as a upon s plus b upon s plus 1 plus c upon s minus 3. Just a minute. Huh? Yes, what happened? Oh, it's loading. Okay, fine. Hmm. So b upon s plus 1 plus c upon s minus 3. Is it right? Take a time and try to complete it. Try to find the constants. Yes. How to find the constant? Where this a is given by, what you have to do? S minus 1 bracket square divided by s into s plus 1 into s minus 3, and in the denominator of a you are having that factor as a s, and for what value of s you have to substitute here? Yes, Vipul Jadhav, what I have to substitute here? S is equal to, now see earlier what we did, the same thing, whatever the factor is there, that you have to put equate to 0 and directly you are getting the value, na? So you have to put at s is equal to 0. So if you substitute s is equal to 0, now here this factor s get cancelled. Minus 1 square, that numerator is minus 1 square is 1, minus 1 square is 1, and the denominator is 1 into 1 into minus 3. So this implies that a is equal to, yes, what is the value? Minus 1 by 3. A is equal to minus 1 by 3. In the same manner, if you go for the, yes, Afia, good. In the same manner, suppose if you are calculating B, then B is given by S minus 1 bracket square divided by S into S plus 1 into S minus 3. Now you are calculating B and the factor is S plus 1. So you have to multiply this by S plus 1 and value of this function. Yes, anyone can tell? Ankita?
-1, sir.
Yes, S is equal to minus 1. Once again, this S plus 1 factor get cancelled. Now the remaining is S equal to minus 1. That means minus 2 square divided by S is minus 1 into minus 1 minus 3 is minus 4. So this implies B is equal to minus 2 square is 4 divided by 4. It coming 1, na?
Yes, sir.
B is equal to 1. Someone written that is 2 in the chat box. That's why I'm asking. Yes, B is equal to 1. Now the next, in the same manner, if you continue for C, that C is given by S minus 1 bracket square divided by S into S plus 1 into S minus 3 and value of this function at S equal to, Sujan, 3.
Yes,
Yes,
sir.
S equal to 3. And if you simplify again, so I forgot to write that factor right now. So multiplied by the denominator factor, and the denominator factor is S minus 3. Multiplied by S minus 3 and value of this function at X equal to 3. Now this term S minus 3 factor get cancelled. Then the numerator is 3 minus 1 is 2, its square divided by 3 into 3 plus 1 is 4. That is C is equal to 1 by 3. Very good. 1 by 3. That is the answer. Substitute all the values. Therefore, inverse Laplace. Therefore, inverse Laplace transform of S minus 1 bracket square divided by S into S plus 1 into S minus 3 is given by L inverse of, I will substitute A as a minus 1 by 3 upon S plus B is 1 upon S plus 1 plus C is equal to 1 upon 3 upon S minus 3. And by linearity, so here I will take minus 1 upon 3 as a common and Laplace transform directly. Can I write the answer?
Yes, sir.
Otherwise, L inverse of 1 upon S plus L inverse of 1 upon S plus 1 plus 1 upon 3 into L inverse of 1 upon S minus 3. So what I did, I am applying linearity property first. I hope that the results are with you. This is 1 upon 3. And what is the Laplace, inverse Laplace of 1 upon S? 1
1.
plus e to the power minus t plus 1 upon 3 into e to the power 3t. From all together, I will take 1 by 3 as a common. If required, you can simplify this. Then first term is 1 plus 3 into e raised to minus t plus e to the power 3t. That is the required answer.
मायनस आहे ना.
कुठला टर्म आहे हो पहिला फर्स्ट टर्म मायनस आहे बरोबर आहे इट शुड बी मायनस बरोबर आहे इथं मायनस First term is minus. I forgot to write this. Then this one is minus. I think it's okay. Fourth example. Find L inverse of, suppose the factor is repeated 5 times. 1 upon s minus 5 raised to 5 into 1 upon s plus 2. I think first one is completed.
Yes, sir.
Now see, before applying partial fraction, I will try to simplify this. L inverse of 1 upon s minus 1 raised to 5 into s plus 2. So the same thing I will write L inverse of I'm going to use first shifting theorem. So that's why I will write this as s minus 1 bracket square into s minus 1 plus 3. Is it okay? X minus 1 plus 3, it become plus 2. And you can observe that everywhere you are having s minus 1 factors. That's why by that first shifting theorem, it can be written as e to the power t into L inverse of something. I made mistake. You should point out that. What mistake I made?
S minus 1 raised to 5.
Very good. It should be 5. That means you are attentive. Okay. Now, if I am playing first shifting theorem, then it is 1 upon s raised to 5 into s plus 3. Suppose this as number 1 I am consider. This one I will consider as a number 1. Then by partial fraction method, I will simplify that. By partial fraction method, 1 upon s raised to 5 into s plus 3 can be written as, so first the factor s is repeated 5 times and that value you are having exactly at 0. Okay, that's why I will represent this term first. So how to represent? It is a naught divided by s raised to 5 plus a1 divided by s raised to 4 plus a2 divided by s cube plus a3 divided by s square plus a4 divided by s. Means we have started with 1 upon s raised to 5 to s, and plus for the remaining it is a linear factor, we may write it as 1 upon s plus 2. Once again I will write the term. What is the formula? An minus 1 is given by 1 upon n minus 1 factorial into n minus 1th derivative of n1s at some s is equal to a. Okay, I will scroll a little bit up. Now in
Sir, B upon S plus 3, not 2.
b upon s plus, I am taking 2. It's very good. It is 3 in the new case. Okay, it is s plus 3. Thank you. Now the next one. Now what is n1s? If you try to find, I explain the procedure. The given function you have to take as it is, 1 upon s raised to 5 into s plus 3. Is it right? Now for this you have to multiply by the highlighted factor. What is the highlighted factor? Pranoti Gaikwad. Pranoti.
Yes, sir.
घेतलंय कोण सांगेल अंकिता
S raised to 5.
एस रेस
Five.
टू 5 हायलाइट केले तुमच्या समोर आहे सो
S
एस
minus
रेस टू
1.
5 मीन्स दॅट फॅक्टर गेट कॅन्सल आता राहतो किती n1 ऑफ एस म्हणजे 1 अपॉन एस प्लस 3 बरोबर आहे नाव this red color I am writing for your understanding n is equal to 1 in the formula then a naught is given by yes if n is 1 1 upon 0 factorial zeroth derivative of n1s. What is the n1s? 1 upon s plus 3. Am I right? And value of this function at s is equal to 0. Okay. Now, 0 factorial is 1. But 0th derivative is nothing but the term itself. 1 upon s plus 3 and value of this function at s is equal to 0. So this implies a naught is equal to 1 by 3. Am I correct? A naught is equal to 1 by 3. Am I right?
Yes.
Yes, sir.
Next, suppose if you are putting n is equal to 2 in the formula, this is a formula, then A1 you are getting. A1 is given by 1 upon 2 minus 1, that is 1 upon 1 factorial d by ds of 1 upon s plus 3 d by ds of 1 upon s plus 3 equal to 0. This is 1 upon 1 factorial is 1, not necessary to write. And what is the derivative? 1 upon x, its derivative. 1 upon s plus 3, its bracket square. Is it right? At s equal to 0. Tell me a1. S is 0, the term is negative. 1 upon 3 square?
Minus 1 upon 9.
Yes, minus 1 upon 9. That is your second coefficient. That is your second coefficient. Now next, for the next, if you put, I will scroll little bit up with this part I require. Suppose n is equal to 3, then next constant. A2 is given by 1 upon 2 factorial into second order derivative of 1 upon s plus 3 and value of this function at s is equal to 0. So 1 upon 2 factorial is 2 into what is the second order derivative of 1 upon s plus 3? Now already one derivative are calculated that comes as this term. Okay. एक डेरिव्हेटिव्ह ऑलरेडी काढलेला आहे तुम्ही मग अजून एकदा हा जो हायलाइटेड टर्म आता मी केलेला आहे वन्स अगेन यू डिफरन्शिएट दॅट व्हॉट इज द डेरिव्हेटिव्ह it comes as a minus x raised to minus 2 form. That is minus into minus 2 into x raised to minus 3. That means 2 upon x cube. मग इथे किती येईल तो टर्म 2 upon s plus 3 bracket square and value of this function at s equal to 0. So here you can notice that this 2 and this 2 get cancelled at the evaluation साठी. Therefore, value of the next constant a2 is value of the next constant is s is 0 1 upon 3 cube किती येणार very good 1 upon 27 1 upon 27 that is the next constant. Now next still we have to find a3 and a4. So next you have to put n is equal to 4. The next constant a3 is equal to 1 upon 3 factorial into third order derivative of 1 upon s plus 3. Okay. And value of this function at s equal to 0. 1 upon 3 factorial is nothing but 6. Now see, this highlighted term is the second derivative. Now this highlighted term, if you differentiate one more time, what is the derivative? Can anyone tell? Ishika? इशिका जादव लेफ्ट. जियाद. जियाद. प्रणोती. सगळेजण झोपले की काय? ओंकार खोत.
6.
Okay,
Yes, sir.
Afia. Yes. Can anyone tell? Sujan or Afia, you can tell. I have highlighted for n is equal to 3. I have highlighted term that 2 upon s plus 3 bracket square. What is its derivative with respect to s?
minus 6 upon s plus 3 raised to 4.
Very good. It is minus 6 upon s plus 3. Its bracket raised to 4. Okay. And this is at s equal to 0. Now here you can notice that this minus 6 and this 6 get cancelled, and value of the term a3, it comes as a negative. I think 1 upon 81, because 3 raised to 4. Right now?
Yes, sir.
Yeah, minus 1 upon 81. That is the next coefficient. One more we have to find. So next one, n is equal to 5. Then this a4 is given by 1 upon 4 factorial into fourth derivative of 1 upon s plus 3 at s equal to 0. 1 upon 4 factorial, value of the 4 factorial is 24. And again, fourth derivative means once again you have to differentiate this highlighted term. What will be the derivative?
24 upon s plus 3 raised to 5.
Yes, excellent. Raised to 5. And value of this function at x equal to 0. Once again you can notice this 24 get cancelled. Now evaluation of the term, I think it's coming as a positive. A4 is equal to 1 upon 3 raised to 5. Yes, anyone? Is it right? If required,
Yes,
this
sir.
one note acts as a calculator. 3 raised to 4 is, no, something wrong. Raised to 5. Raised to 5.
240.
Raised to 5 I have to calculate.
240.
Yeah, 243. Okay. These constants you have identified for the non-repeated factor. So next you have to find B. Next you have to find B. Now that B can be calculated in the regular way. So this B is given by 1 upon s raised to 5 into s plus 3 multiplied by s plus 3, and value of this function at s equal to, right now, minus 3. So this s plus 3 factor get cancelled. So the remaining is 1 upon s raised to 5 at s is equal to minus 3. So this implies b is equal to, the term is coming negative. 243, because already you calculated na that. So this is 1 upon 243. Okay. Therefore, this inverse Laplace transform I am writing directly. Which one? This one. This one I am writing, and that value I will substitute in equation 1. So thus, therefore, L inverse of 1 upon s raised to 5 into s plus 3, this is given by L inverse of first term a naught is 1 by 3 upon s raised to, yes, what is the term? Upon s raised to 5 plus minus 1 upon 9 s raised to 4 plus 1 upon 81 s raised to 3 minus, I think I made some mistake. You should identify this is 1 upon
1 upon
it's, a,
27.
it's okay, Ishika, don't worry. 1 upon 27, then 1 upon 81 upon s raised to 2 plus 1 upon 243 divided by s minus 1 upon 243 divided by s plus 3. Is it right? Now, two steps I'm writing directly, linearity property and its answer. So first one, 1 by 3 as it is. What is L inverse of 1 upon s raised to 5? Is it right?
Yes.
Okay, next. Minus 1 upon 9 into t raised to 3 divided by 3 factorial plus 1 upon 27 into t raised to 2 divided by 2 factorial minus 1 upon 81 into t raised to 1 divided by 1 factorial plus 1 upon 243 into t raised to 0 divided by 0 factorial, or L inverse of 1 upon s is t 1, that also you can write 1 upon 243 into e to the power minus 3t. So tell me the step after simplification. Suppose I am taking 1 upon 72 as a common from all these. What is the remaining term? Now first term. First term.
T raised to 4.
Yes, very good. It is t raised to 4. Next, second term. It coming as a 4 by 3. Huh? You have to make the adjustment, verify it. It's coming as a 4 by 3 t raised to 3 plus next term.
4 by 3.
Again 4 by 3 t square. Next term 8 by 9 t plus 8 upon 27, that constant term. And suppose last term I'm writing as it is 1 upon, I think again I made some mistake, or it is okay. I think it's correct. 1 upon 243 into e to the power minus 3t. So that value you have to substitute in equation 1. Therefore, equation 1 becomes, what is the equation 1? I will copy that if required. So this is the equation 1, this part. Control C. The same thing I will copy here. So this equation you are simplifying. This equation means what? This one I will remove. Now, this is for your reference. Whatever answer you are getting, for that answer you have to multiply by e raised to t. E raised to t into 1 upon 72 into bracket t raised to 4 minus 4 by 3 into t cube plus 4 by 3 into t square minus 8 by 9 into t plus 8 upon 27 minus 1 upon 243 into e raised to minus 3t. Okay. Now next step, simplify the answer. That e raised to t can be multiplied inside the bracket. So first term becomes e raised to t divided by 72 into first term t raised to 4 minus 4 by 3 t cube plus 4 by 3 into t square minus 8 by 9 into t plus 8 upon 27 minus 1 upon 243. What should I write in the power? What I should write? Because this e raised to t you are multiplying with this term. Yes,
-2.
e to the power minus 2t. Okay, this is the final answer. This is the final answer. Any doubt? So very in rare cases such type of examples will come. If any doubt we will take, otherwise we will move to the next one. Fifth example, suppose find L inverse of 2s plus 5 divided by s square plus 13s plus 36 its bracket square. Yes, I will consider that term separately. Suppose 2s plus 5 divided by s square plus 13s plus 36 its bracket square. Once again, the question is, what is the degree of numerator?
One,
It is 1. And degree of the denominator?
two.
4. 4, not 2. Because square and again it's square. Finally, the contribution is 4.
Yes, sir.
Okay, that's why we can apply partial fraction method. So before to that, now that is a quadratic equation, and this 36 can be splitted as 9 and 4. Okay, 9 and 4, their product is 36 and their sum is 13. Means what? The two factors, this can be written as 2s plus 5 divided by, the two factors are given by s plus 4 and s plus 9 to the whole square. Am I right?
Yes, sir.
Yes, sir.
Means further it can be written as 2s plus 5 divided by s plus 4 its bracket square and s plus 9 its bracket square. Now this is the case where both factors are repeated. Suppose I am writing corresponding to s plus 4 bracket square, I will use a constant a. So I will start with a naught upon s plus 4 its bracket square plus a1 upon s plus 4. So the effect of sub first repeated factor is over. And for s plus 9 bracket square, I will take a b as a constant plus some b naught upon s plus 9 bracket square plus b1 upon s plus 9. So once again, I write the formula for your reference. Suppose first is related to s plus 4 factor. The constant an minus 1 is given by 1 upon n minus 1 factorial n minus 1th derivative of n1s at s is equal to a. Now what is n1s in the first case? Can I write directly? What is n1s? Up here, what is n1s?
Yes, sir.
What is n1s in the first case? Suppose this I am considering as the first case related to s plus 4. What is n1s? That is my question.
S
1
plus
upon
4
s plus 4
plus
square.
1 upon s plus 4 चा स्क्वेअर का s plus 9 चा स्क्वेअर?
S plus
हे बघा, 2s plus 9 divided by s plus 4 bracket square plus s plus 9 bracket square. आता मी कशाने मल्टिप्लाय करायला पाहिजे? ए नॉटच्या
S
खाली s
plus
plus 4
4.
आहे. So
Just
that's
it.
why s plus 4 it's a square. The remaining is 2s
2s
plus
plus
9 divided by s plus 9 its bracket square, because these two factor, that means these two factor get cancelled. Okay, first I will calculate these two. Now, where a naught is given by 1 upon 0 factorial into 0th derivative of n1s is 2s plus 9 divided by s plus 9 bracket square.
2s plus 5, sir.
5 is there?
Yes, sir.
Yes, sir.
Numerator 2s plus 5. Yes, numerator is 2s plus 5, s plus 9 bracket square, and value of this function at s is equal to -4. Now it comes as 0th derivative, means that original function it is 2s plus 5 divided by s plus 9 bracket square. Value of the function at s is equal to -4. This is, when you substitute s is equal to -4, it comes as a -18 plus 5 divided by -4 plus 9, means 5 square is 25. That means a, a naught is a naught is
Sir,
Afia,
-8 plus 5.
minus 9. S equal to -9 or minus.
just a minute. What happening? S equal to, just a minute, I will check. S equal to, correct. It is -8, right now? Yes. 2s means 2s are 8. Yes. -8 plus 5 divided by 25. What is the constant then?
Minus 3 by 25.
That's
-3 by 25. Yes. That is the first one term, suppose. Second one, a1, suppose if you are finding, a1 is given by 1 upon 1 factorial d by ds of 2s plus 5 divided by s plus 9 its bracket square, and value of this function at s equal to -4. Now you have to find the derivative. Now can I find, can I calculate derivative to the right side? This part, directly I will write d by ds of 2s plus 5 divided by s plus 9 bracket square by quotient rule. By quotient rule, s plus 9 bracket square into derivative of numerator 2s plus 5 into derivative of denominator is 2 into s plus 9 divided by s plus 9 its square and square. Means from this I can cancel one factor of s plus 9. The remaining term is 2 into s plus 9 minus 2 into 2s plus 5 divided by s plus 9 its bracket cube. Now further I will not simplify, I will take that as it is. So 1 upon 1 factorial is 1, not necessary to write, and derivative is given by 2 into s plus 9 minus 2 into 2s plus 5, that whole divided by s plus 9 its bracket raised to 3, and value of this function at s equal to -4. Can you evaluate and tell the value? A1 is equal to, because what happened if you simplify this, 2 into s is -4, -4 plus 9 it's 5, -2 into -8 plus 5 divided by it comes as a 5 raised to 3. Yes. Yes, anyone?
16 by 125.
Correct. It is 16 divided by 125. So can you follow the same step for B? So this is 16 divided by 125. Now for B, formula is same. Suppose the second factor for B, what is N1 of S if you are calculating? What is N1 of S in the second case? So डायरेक्टली ह्याच्या खालचा येणारा हा टर्म काढून टाका मेन फंक्शन मधनं. काय येणार? 2s yes 2s plus 5 divided by s plus 4 its bracket square. बरोबर आहे? s plus 4 bracket square. Now in the same manner, then b1 is given by 1 upon 0 factorial 0th derivative of 2s plus 5 divided by s plus 4 its bracket square, and value of the function at s is equal to minus 9. That becomes
सर ते बी झिरो येणार, बी नॉट येणार ना सर, ते बी
b not
नाही
येणार.
येणार.
हो हो b not येणार, बरोबर आहे. 2s plus 5 divided by s plus 4 its bracket square at s is equal to minus 9. So it is minus 18 plus 5 numerator आणि minus 5 चा square always positive. This is b1 is equal to, सांगा बघू. बरोबर आहे का लिहिलेलं मी? minus 13 upon 25. So in the same manner, this b1 next constant, this b1 is given by इथं b0 पुन्हा b1 लिहिलंय, it is b0. So the next one, b1 is given by 1 upon 1 factorial d by ds of 2s plus 5 divided by s plus 4 bracket square, yet s is equal to minus 9. I will scroll little bit up, and suppose again I will find the derivative here. D by ds of 2s plus 5 divided by s plus 4 bracket square, which is given by numerator s plus 4 bracket square into derivative of numerator 2s plus 5 into derivative of denominator 2 into s plus 4, that whole divided by s plus 4 bracket raised to 4. पुन्हा तुम्ही याच्यातला एक टर्म कॅन्सल करू शकता. 2 into s plus 4 minus 2 into 2s plus 5, that whole divided by s plus 4 its raised to 3. बरोबर आहे? एक टर्म कॅन्सल झाला. कुठून? s plus 4, s plus 4 and s plus 4. So the same thing I will write here. So which is given by 2 into s plus 4 minus 2 into 2s plus 5, that whole divided by s plus 4 its bracket raised to 3 at s is equal to minus 9. सांगा बघू. minus 9 जर टाकला तुम्ही तर हा टर्म आला minus 5 into 2 is minus 10 plus 2 into 13 ना
minus 30.
सर मायनस येणार, प्लस नाही येणार.
हा पण मायनस येणार, हा पण मायनस, त्यावेळेला प्लस होणार ना. आउटसाइड इज ऑल्सो मायनस ना.
ओके ओके, डायरेक्ट केलं हा
हा
चक्कर.
आता इथं -5 हा टर्म बघा, -9 + 4 इट्स ब्रॅकेट क्यूब किती येणार?
125.
मायनस ना.
minus 1.
So the total effect, if you are calculating, then B1 is given by minus 16 upon 125. Minus 16 upon 125. Therefore, required term, little bit I will, okay, this much is fine. Therefore, L inverse of, therefore, I will substitute all the term. L inverse of given term, what is the numerator? It is 2s plus 5, na? 2s plus 5 divided by s square plus 13s plus 36, it's bracket square. Two steps I will write directly. One is the linearity property, and second one I am substituting the constant. Minus 3 upon 25 into L inverse of 1 upon s plus 4 bracket square, first term, plus 16 upon 125 into L inverse of 1 upon s plus 4 minus 13 upon 25 into L inverse of 1 upon s plus 9, its bracket square. Sorry, it is minus again, last one. Something, both are minus, B0 and B1. Yeah, both are
Yes.
minus. Minus 16 upon 125 L inverse of 1 upon s plus 9. Now here first step, minus 3 upon 25 into e to the power minus 4t by first shifting theorem, L inverse of 1 upon s square plus 16 upon 125 e to the power minus 40, that's it, minus 13 upon 25 into e to the power minus 9t into L inverse of 1 upon s square and minus 16 upon 125 into e to the power 9 minus 90. So one more step you have to simplify. I think little bit these examples are tough. Minus 3 upon 25 into e to the power minus 40. What should I write?
T.
It is t, right? It is t plus 16 upon 125 e to the power minus 40 minus 13 upon 25 e to the power minus 90 into t and last step minus 16 upon 125 into e to the power minus 90. So after that what I will do, I will collect e to the power minus 90 terms together and e to the power minus 40 term together. Suppose e to the power minus 40 divided by, I will take 125 as a common. Then what will the remaining? Suppose I am writing first this term. 16 बरोबर है, minus काय सांगा, you have to multiply by numerator and denominator by 5, means 3 into 5, correct? In the same manner both are negative. Suppose here I take e to the power minus 90 divided by 125, then both terms are positive. 16 plus 15 threes are 65 t, and that is the required answer. That is the required answer. I think that today example is little bit tough. Again, some more tougher examples I am going to continue with the next lecture. If any doubts, we can discuss. Otherwise, I will shift to the attendance.